Okay, so as we discussed regarding the SNS that works on the publisher subscriber model. So similarly, we have another service that will also help us to implement the publisher subscriber model, that is using the Redis. So primarily, as we know, the Redis is used as a in-memory database and mainly for the caching. So at the same time, Redis can also be used as a publisher for the publisher subscriber model. Okay, so here let's first discuss regarding the how Redis will help us into the publisher subscriber model, and then we'll see how to implement that practically. We'll just see a simple demo of this, and then we'll discuss what exact difference between the Redis publisher subscriber and AWS SNS. So what are the major differences and where it can be used. Okay, so let's get started with this example. Okay, so in this example we'll discuss about a messaging system. So as we all know, the messaging system works on the WebSocket, right? So here let's say we have a team of around 80 people. Okay, so why I'm taking this count, I'll just let you know. So let's say we have a team, and in this team we have 80 members or 80 resources. Okay, and we want as an organization to establish a communication system to manage these 80 people. Okay, so now in this case, if we have, let's say, only one server, and through that one server all the 80 people have established the connection and they are able to transfer the messages. Okay, so is that possible? If the server capacity is less, that's not possible, right? Because every server can handle up to some limit of connections. Okay, so let's say if we have one server and its limit is 10, then in that case how many we need? We'll need around 8 such servers to handle the 80 people, right? So that's the reason here we have 8 servers. Okay, so each server will get 10 connections, and in that case all the 80 people will be connected to the all the different servers. Okay, but now let's say there is a person one connected over WebSocket to the server, let's say 1. So this is the, let's say, first condition, and here let me just rearrange this, and here let's say this person 1 wants to make a communication to the person, let's say 11. Okay, so now in this case person 11 is, let's say, currently connected over WebSocket with the server 2. Okay, so if both the person 1 and person 11 were connected to the same server, let's say if they were connected to the, let's say, server 1, then the message flow would have been very simpler, right? So both will be connected to the over the WebSocket. So the person 1 will send us a message and that will hit to the server, and that server will just forward that message to the person 11. But if they were in the same server, but now in this case what's happening, person 1 is connected to the server 1, but and person 11 is connected to the server 2. That's a different server, and both are connected over the WebSocket. But now how will the server 1 will send it to the server 2? Okay, so here for that it needs to make a direct call. Okay, now that's a case when there is just a one person. But now if, let's say, this message we needed to send it to the multiple people who are there in the organization. So now in this case I need to make multiple requests to the multiple servers. I hope you're getting the point. Let's say instead of person 11, I want to send it to all the 80 people, all the remaining 79 people. So in that case, all the 7 people are connected to the different servers. So now from the server 1, I need to make a separate calls to all the servers so that that message will get broadcasted to the other users over the WebSocket. So this is an ideal condition. But now here, just look how many network connections we are making, network calls we are making. So first I need to make calls to all the servers, then servers will be sending it over the WebSocket. So here we are having a very high network overload, right? So this is where we can introduce the Redis kind of publisher subscriber model that will help us to reduce this network overload. So how that can be done? So instead of sending the messages to all the servers, so we will introduce a Redis publisher subscriber model or Redis server here. Now what will happen, that all the servers will be subscribed to this Redis server. So now the moment the message is sent to this, Redis server will publish that to all the subscribers. Okay, and in this way all the recipients will receive the message. And unlike doing multiple network calls, and here we just did one network call and then all the recipients got the messages through this publisher subscriber model. Okay, so now let's discuss how this can be implemented. Let's see a simple demo that will give you an idea about how this works. Next we'll see the difference between Redis PubSub and the SNS. So to make you understand this, I have created a simple Spring Boot application, and here first of all I have created a Redis server using a Docker container. So here you can run this command that will pull the Docker image and create the container, and that will run on 6379. So currently the Docker is running, like Docker container having the Redis server is running. Okay. Next, to make communication or the connection to the Redis server from the Spring Boot application, we need to add a dependency. So the dependency here I have added is Spring Boot starter data Redis. Okay. So this dependency will help us to connect to the Redis database. Next, in the application.properties, we have just added a simple host and the port over which it will make the connection. And now coming to the configuration and the setup. So first of all, here we'll have a Redis configuration. So in the Redis configuration in the container class, we'll first create the Redis template. So this Redis template is needed to send the message to the Redis server. So as we know, the Redis, the message is sent in a key value pair, right? So here, first of all, we need to define the serializer for both the key and value. So here we are setting the serializer for key as a string Redis serializer, and for value, we are keeping it as a generic Jackson to JSON Redis serializer. So basically the value is of type JSON and the key is of type string. Okay. So this is where we are adding the serializer for key and value, and this Redis template will use to create the message, and then we'll send it over. So that is the first bean that will get created when the application boots up. Next, we have the configuration part regarding the topic. So here, as in the SNS, simple notification service on AWS, similarly here we'll need to create a topic, and that topic needs to get registered with the Redis server. So the first step here will be to create this topic. So let me just move it up. Okay, so here we create this topic, and here I have did it manually, and we can also automate this. So here the topic will be created as the user event. Now this topic, to get registered, we need to pass this topic into this container. Okay, so now let's understand what is the role of this container. So this container here is helping us to create this topic and register this server as a subscriber. So here, first of all, we are passing the Redis connection factory. So this will be injected by the Spring Boot as we have added this dependency, Spring Boot starter data Redis. So that will be connection factory will be injected at the runtime. Next, here we have passing the second parameter, that is user subscriber. So this user subscriber is our component that is implementing message listener. So here this message listener will help this application to act as a receiver. That is, it is going to receive the messages. So that's the reason here we are overriding the on message method. So that is going to receive the message. So here we are passing it over here, and now these two are passed over here where we are creating the Redis message listener container, and into that container we are passing the connection factory, and next we are passing the user subscriber where this will receive the message, and here we are passing the topic to which it wants to get subscribed. So whatever the messages that are sent over that topic, it is going to receive that message. Okay. So this container will get created when the application gets started. So when this code gets executed, when the application starts, so this is what exactly happening. So let's say this is our application, that is the server 1, let's say, and when that code gets executed, a user event topic will get created in the Redis server, and that topic will get subscribed by this server. Okay. Next, let's discuss who is the message sender here. Okay, so for that we need to go to the message publisher. So this message publisher is again another component where we are using the Redis template that we created as a bean in the Redis config class. Next, this Redis template is used to send the message over a topic, and here I am auto-wiring the topic, and I'm using the @qualifier annotation here. So this @qualifier annotation will make sure that which topic I'm referring to. So here it is referring to user topic. So if you go back to Redis config, so here we have created the bean and we are not explicitly mentioned here. So we need to add it over here as a name, that is the user topic. So whatever the topic it is referring to, that topic will be injected over here in the user publisher. Now, why this is needed? Because let's say if we want to add another topic, so let's say we have added another topic. So now in this case, let's say the topic is user details, and let's say it's a topic 2. So in this case, if we have not added the name explicitly, then it will create an ambiguity that which topic has to be injected in the user publisher, right? So that's the reason we are using @qualifier here. And if we have a second topic, then this server, that is this server right now is subscribed to only one topic, but you can also make sure that this server, if you want, can subscribe to another topic as well. So to do that, here what we need to do, we need to add another line of code here, that is container.add message listener user subscriber, and instead of topic 1 here we need to make it as topic 2. Okay, so with this server will now get registered to 2 topics, that is user topic and user details, right? So now whatever the messages sent over here, that will be received by this server. So now let's say this is the another server that is going to send the message over user details or user events. So that message will be sent to the Redis server, and the Redis server will know which all servers are subscribed over this topic, and that server will get that message. So that is what here I am doing in the user publisher. So basically this server is acting as both producer and consumer. So this here I am acting as a producer, where I am sending a message over this topic using the Redis template. And here the key is of type string and value is of type JSON. Okay, so that's all here, which from the configuration point of view, we have added a user publisher and user subscriber within the same application, but it usually will be there in a separate applications. And here I have a user model having the user ID, name, phone, and email. And in the user DAO class, I have a save method that is going to call this publish method. So first of all, I'm having a API that is a post API that is getting the user details, and this will be called, this is going to call the user save method in the DAO class. And this DAO is again further going to call the publish method in the publisher. And finally, that message will get published over here in the user events, and then that can get consumed by the subscriber. Okay, so let's send the message and let's check whether the publish subscriber model is working or not. So before that, we did some change. Let's just revert that in the config as we don't need it. Okay, so let's start this application. Okay, so application has started. Now let's go to Postman. So here in the Postman, I'll be sending this data over the post request, that is this user data. Let's see. Okay, so we got the response, and let's see whether we got it over the subscriber or not. So here we have subscribed it, and once we have sent it, so this user publisher sent that message to the pub sub, that is the Redis, and from there we have subscribed it over here in the on message. So ultimately we are getting that message over here. So I hope you were able to understand this simple demo of how the publisher subscriber model works with the Redis. Next, let's see what are the major differences we have with in comparison to the AWS SNS. Okay, so here let's understand the major differences between the Redis Pub Sub and the AWS SNS. So the first major difference is the latency. So as we know, the Redis Pub Sub can be used for the communications as we discussed over here, for the communication within the microservices. So if we want to broadcast the message within the servers or the services over a low latency, in such conditions, this Redis Pub Sub can be used, and not for the real notification systems where we want to broadcast the messages over to the millions or billions of users. So that's not ideal to use the Redis Pub Sub over there, and it is ideal for this kind of scenario. So and where we need a low latency, right? So when just imagine the messaging system where we immediately want to transfer or broadcast the messages, right? For such condition, we can use the Redis Pub Sub. And here it's an in-memory communication, and because of in-memory, this makes it very fast. And inside the application environment, this can be used as we just discussed, like a walkie-talkie. So walkie-talkie is just an example or an analogy that can be used over here. Next, when we compare that with the AWS SNS, this can be used for the global event distribution that we have already discussed in the previous video, where it can be used, and it's more durable. As we know, it has a retry mechanism. If the subscriber is down, it will just retry the messages to be sent, but that's not the case with the Redis Pub Sub. If the Redis receiver is down, then that message will get missed. So that's a major difference. And here the scalability is one of the very critical difference here. So for scaling the Redis Pub Sub, it is a manual task. We need to set up the cluster, but AWS SNS scales on the fly. We don't need to manage this. And here we can use this across the microservices or regions. And that is not the case over with the Redis Pub Sub. So it can be used, but we need to set up that manually in the multiple regions. But this can be done on the fly. And it's like a mobile network. If we want to analyze these two with an analogy, then this is like a walkie-talkie that works within a radius, but this is like a mobile network that works in a larger area, right? Next, if we consider the message durability, so here it does not store the messages, message is gone if subscriber is offline, as I said, and it is real time only. But AWS SNS stores and retries the messages, and the guaranteed delivery we can get it, and it is more reliable compared to the Redis Pub. Okay, so that's regarding the message durability. Next, coming to the scale, as we already just discussed. So it gives high throughput, definitely, and inside a single Redis cluster, we need to set up that, and that can be used for the internal microservice communication. But when compared to the AWS SNS, it helps us with a massive global fan out, which we already discussed in the last video. We can have millions of subscribers and can be established in multiple regions. And this can also be used for the cross service or account or region distribution, right? So basically AWS SNS helps us in the setup that can be implemented over vast regions, but that is not the case with the Redis Pub. So both of them serve the completely different purpose here, and supported subscribers here. If you use Redis Pub, then it must be connected to the Redis all the time. But with the AWS SNS, as we know, in our case we used SQS, but along with that we can also use other AWS services like Lambda, and you can also integrate that with SMS service or email service. Like, we can have all these options to integrate with AWS SNS, but with Redis Pub, we has to be connected to the Redis all the time. Okay, so that's the other difference we have. Then coming to the use cases, this can be used for the chat messages kind of applications, for the live updates, and in the WebSocket notifications, real-time dashboards. Then coming to the AWS SNS, this can be used for the event-driven microservices for fanning out the messages and triggering the lambdas, right? So there are the use cases are completely different. So basically we cannot replace one with the other. Okay, so this is used where we need a low latency and within a smaller environment. But this can be used where we have the larger use case or larger serving area, and we need the more durability. In that case, we can use AWS SNS. Okay, and coming to the setup part here, AWS SNS can be set up very easily because it's present on the AWS. But Redis pops up, we need to manually set it up. Okay, so I hope you were able to understand the major difference between these two messaging systems, and that helps in the asynchronous communication. Okay, so next let's look at the next service.